Okay, so I'm going to talk about the miniature ceramic ion trap mass spectrometer chip. This is a miniaturization of the original cylindrical ion trap. And this is favorable for chip-based mass analyzers since their geometry is based on planar layers that may be easily miniaturized. This chip is made out of DuPont ceramic paste, metal inks, carbon paste films, and it is co-fired for better results. It has a metal thin layer that allows to put some voltage inside the chip, the ion trap, and then we can obtain the results that are shown here at the bottom when for clear results of the materials or the elements that compose any sample that we can analyze and with very accurate results. This chip can be used in military fields. It can be used by law enforcement officers, and it also can be used for portable laboratories, as I mentioned, in the military fields, or maybe for police officers it can be portable in their cars. It is composed by three parallel plate electrodes, I'm sorry. And it's the way it works is by the central ring, it is apply an RF voltage, and it is surrounded by two parallel end cap electrodes that usually are has a ground potential. These two electrodes form a dual capacitor and that are part of an oscillated LC tank circuit. This way, the charged particles enter the trap through the concentric holes, and once the ions are trapped, they may be scanned out of the trap from low to high mass by increasing the RF voltage. This way, we generate a
Yeah,
mass
it's recording
spectrum.
now. Okay.
The size of this chip, it's about 10 millimeters by 10 millimeters. It's a very small one. It has since I mentioned before, it is coal-fired. It has a shrinkage of about 14% from the green materials to the final product. This ion trap is being used in the Griffin portable gas spectrometer, and it's very accurate from since it's been modeled from a big device to a miniaturized one, and the goal is to bring it to even smaller size so it can be portable, as I mentioned at the beginning. The voltage, the RF voltage range that can be applied to this device, it oscillates between 185 volts to 116. I'm sorry, 1,600 volts, and the scanning range oscillates between 220 to 2,000 for an accurate result. The RF module voltage scanning range must be modified to shape this range to is that the voltage that I mentioned before is the usual voltage that it's applied to the this is the initial applied voltage that is between 185 to 1,600 volts, and for the usual cylindrical ion trap. But for this ceramic ion trap, the miniaturized version, the voltage range is between 40 volts and 1,400 volts to cover the maximum mass scanning range that is between 50 to 1,650 decibels for the CCIT. The next steps to meet this goal is to implement the RF module voltage to mass range scaling solution, the fabrication of the new ceramic cylindrical ion trap chips for testing, the performance of test and calibration of this CCIT with FC43 mass range resolution and power consumption, the development of the CCIT spectra for the FC43 for drugs and explosive mixtures, the CCIT chip field replacement assessment, the extended mass range performance characterization, and the analysis of CCIT spectra performance and performance results versus the original version of the cylindrical ion trap, that is the G460, and make the corresponding reports for these results. There has been some tests that have been performed with this ceramic cylindrical ion trap, the miniaturized version. And we can see here the results today compared to the laboratory results obtained before. And we can see that they are very accurate from the G460 CIT and the very first performance test for the ceramic cylindrical ion trap chip.
I had a question. When you say miniaturization, how miniature are we talking about?
It is 10 millimeters by 10 millimeters. It's the size that we obtain at the end when we co-fire the ceramic layers, and it shrinks. Usually this chip is for the original for the original gas spectrometer, mass spectrometer. It's a big chip, and the space that it's contained, it is usually bigger, as it shown in the picture for the Griffin portable. That is the size of, maybe comparing to it's a table table device, which is the size of we can say the size of a microwave, and it's pretty big. Right now, the size of this chip, as it's shown here, it's really small. It's miniaturized, as I mentioned, for the size is 10 by 10 millimeters, and it's a very small scale for the usual ion traps that have been used in the laboratories until now.
And that miniaturization doesn't affect the sensitivity adversely?
No, the range varies because usually the voltage applied to the usual ion traps is for the usual cylindrical ion traps is between 185 volts and 1,600. For this chip, we have to we are able to reduce this gap from 40 volts to 1,400 volts. That allows us to cover the range that usually the cylindrical ion traps or the gas mass spectrometer shows as a result. And it's better because we cover one part that is not covered between with the usual device, because usually the voltage applied is higher, and we can go here from the lower voltage that covers a very wide range of elements of composed that the sample may have.
And when you mention samples, does this limit the types of samples that you could analyze, or does it expand the types of samples?
I'm sorry, the goal is usually, it is applied to a gas mass spectrometer. Usually the samples are gas. The idea of this chip is to amplify the range and be able to not only apply to gas samples, but to solid and liquid samples. That is why one of the next steps is to test in drugs, explosive mixtures, or FC43, is where the samples have been tested, and usually this is a liquid sample. So the idea is to cover a wide range of samples and materials.
And that was, thank you for leading to my next question, which was where do you see this being applied next? And you said drugs and other types of liquid or other types of samples.
Yes, that's the idea. The idea is it's been tested in the SC43, but the idea is to test on drugs and explosive mixtures, so we can have a. There are some materials that the range that where they are detected is lower in voltage. They've been charged in a lower voltage. So the idea is to cover this lower range so we can expand not only to gas samples, but to solid and liquid samples that we can show a better range of result.
And if this were to be, I guess, integrated into an operational laboratory's protocols, would there be what would the cost difference be? Would it cost a bit more, cost a bit less? How do you see that working into a laboratory's potential budget?
This is a disposable device. That is why it's made out of ceramic layers, and it makes it gives the device a longer life, to say in any way. And since it's disposable, the idea is to make it to lower the cost as possible, because right now the devices that exist in the market usually is the whole part that has to be replaced, and it is really expensive for the laboratories when this cylindrical ion trap fails. And the idea for this device is to make it simple to replace just the chip and not the whole part, and that makes this device more affordable than the actual ones that are in the market.
So that really pushes the need for it to be able to analyze a range of samples, because then if it's cheaper and it makes it easier, then that's going to be a huge benefit to the laboratories.
That is why this research has been so successful in that field, because they not only for labs, for the tabletop devices, but the idea is to make them portable, and that way the law enforcement officers don't have to take the labs to the samples to the lab and wait for the results, but they can analyze that on site. So when they can have the results right away when they put the sample inside the device. There is another classmate that is Thomas Baca, that he is working with his group and on senior design in the actual device to miniaturize not only the device, the chip itself, but the device as well, so they can show how it is going to work, how is the ideal working for this device on the field.
Do you think this has applications outside of forensic science, like say maybe customs or border patrol or food safety or things like that?
Yeah, maybe, but for customs, also be useful, because since the objective is to make it a portable device, a portable laboratory device, they can analyze the samples and the dogs at the airport, for example, can test and can detect, and they can analyze the samples right away, and they can have confirmed results or discard whatever is the result, and they can have more accurate response to the officers, to the sorry, I was reading the chat, to the officers, and they can have very quick results for them. It can also be applied for them, since the initial the potential applications are focused on the law enforcement organizations and divisions, but it can also be applied to those type of fields of areas.
Interesting. Do you think, in terms of toxicology, this would have any benefit, or are you right now just looking at solid dose types of samples, as far as drugs are concerned?
Initially, it's been applied only to those concerns. That is the main focus of the research right now. But it can also be tested on a later time that for those type of samples and try to get the most accurate results since it has a wider spectrum.
And it seems like if it could accept liquid samples, that would be beneficial for toxicology, since they seem to, that's how they tend to come initially anyway. So they could simply do a little homogenization and put it on the device and get an answer.
Yes, that's the goal that we try to meet, to be able to analyze not only gases or not, because usually the officers that are in field, they don't have the experience of this of a scientist in the lab to maybe put some type of chemicals on the sample and make it able to read it on the device. That is why the goal of this device is to be able to analyze any type of sample and to get the most accurate results.
Excellent. Is there anything else about this research that you want to discuss?
Not really. We haven't had that much time to test since the current situation, but we are working towards make more tests and fabricate more devices in the future days so we can present more results, more successful results for this research.
One last question that just occurred to me. How long does it take to fabricate one of these devices?
It's a very quick process. We can say that a whole stack of devices from one ceramic layer, we can take out of about 4 or 5 devices. So in a whole day, we can fabricate let's say that a whole day of 8 hours of working, we can fabricate around 20 devices. So it's in a laboratory. I'm not talking about manufacturing industry, fabrication of this device, but in a laboratory, we can fabricate daily around 20 devices.
Okay. That we have someone who entered the talk late. Could you just briefly give a quick summary of how this works?
Sure.
That's okay. Okay. Thank you.
No problem. This is a miniature ceramic ion trap mass spectrometer chip. It is the miniaturized version of the cylindrical ion traps that is found inside the mass spectrometer. And the idea is to make this device portable to be applied in the industry, in the military industry, the law enforcement industry, so they have the ability to have a portable laboratory device on the field, so they don't have to bring the samples that they collect from any scene and wait for the laboratory to test them, but have the possibility to test right away on site. This device, it's made out of the ceramic paste, the metal ink, carbon paste films, and it has 2 3 metallic layers that are charged with an RF voltage, and it's surrounded with 2 parallel end cap electrodes that are usually at ground potential. And this device forms a dual capacitor as part of an oscillating LC tank circuit. This device is charged with the RF voltage, as I said before, and the particles enter and are charged inside in the core of this chip. They exit to the trap through the concentric holes located in these plates, and the ions are trapped and scanned to get the spectrum, the mass spectrum of any of the components or the elements that are inside the sample. The benefits of this device, of this chip, is that it is the range, the voltage, the RF voltage that it's applied, it's lower than the usual for the tabletop containers. Oh, I'm sorry, mass spectrometer. Those are usually between 185 voltage RF and 1,600 volts RF. And this chip allows us to start at a lower voltage, that it's 40 volts, and we go up to the 1,400 volts RF. That allows us to cover more of this spectrum of the, to charge more particles that are not usually charged when we are using the common gas spectrometer, the mass spectrometer. And there are several benefits for the law enforcement industry and the military industry. I don't know if there is any question, any specific question for from the poster.
Are there any other specific questions? Okay. Well, Anna, thank you so much for this. That's in my discussion with you, that sounds like an incredibly promising line of research. And I really hope you get to go back to the lab soon.
Hopefully, we're trying to go back as soon as possible so we can start testing and fabricating more of these devices that are really promising for the industry.
It certainly sounds that way. I want to thank everybody for attending. Anna, thank you so much for this poster and your presentation.
No, thank you so much for inviting us and for attending this poster presentation.
Thank you, everyone.